Hi everyone, thanks for joining me today. Today I'm going to talk about matrix multiplication, and our learning target for today is going to be to understand the rules that define matrix multiplication and their reasons for being. And in order to be successful at that learning target, we need to continue to make sure we're using that proper matrix notation. We're going to determine the possibilities of being able to even multiply two matrices together. And if it is possible to multiply those matrices together, we're going to actually know how to multiply those together. Not all matrices can be multiplied together. Just like when we were adding matrices in the previous video, there were certain requirements or criteria that has to be met in order for us to be able to multiply matrices together. So in order to multiply, it is going to be dependent upon the order of the matrix. And if we remember, order has to do with the size of the matrix. So let's just say we had some matrix A, and I'm just going to put little brackets underneath it just to signify that it is a matrix. I'm not going to put the elements in there. I'm just going to write this as a pictorial kind of demonstration, right? And I'm going to give an order to matrix A, and I'm going to say the order is m by n. So if we remember when it comes to order, oops, I apologize. Something like this, right? When it comes to our order, the first number is the number of rows, right? And the second one is the number of columns. So in other words, matrix A has m rows and n columns. And then let's say we have matrix B. So we know this is our matrix. And I don't know, let's say that this is an S by T, right? So it has S rows and T's column. So I want to know if I can multiply these two matrices together. So I want to know if I can do A times B. So we need to start by looking at the order. So the order for A was m times n, and the order for B is S times T. Matrix multiplication requirements state then that this n times s, or ns, those numbers, have to be the same. So in other words, n is our column for the first one, and s is the row of the second one. So the number of columns for the first one has to match the number of rows for the second one. And when we actually get in and do an example with some numbers, it starts to make more sense why that is true. And then if those are the same, these outers, m times t, that will become your new order of your matrix after you multiply those together, right? So let's write some little notes over here. So in order to be able to multiply two matrices together, that n has to equal s, right? So in other words, the rows of matrix A has to equal the number of columns in matrix B. Okay. If you go to do these problems, and as soon as if that n times that s, if those do not equal, it is going to be, you cannot multiply the matrices together, and it is undefined. And again, when we get to doing those examples, you'll see we can't define what we're supposed to do. We hit this little wall, and it's like, I'm stuck. No, I don't know what to do, right? And lastly, we sat there and said that m times t, that is going to give you your new order. Let's try a couple examples of just seeing if we can actually multiply matrices together and what those new orders might be. So let's just make up a couple. Let's say we have matrix A again, and it's some size. And let's say that that one is a 3 by 2. And let's say we have matrix B, And let's say matrix B is a 2 by 4, right? So that means it has 2 rows and 4 columns. And let's go with matrix C. And that will be a 3 by 3 matrix. 3 rows and 3 columns. So I want to determine if I can multiply some of these together. So let's try example 1. Can I multiply A times B? So the first thing I need to do is I need to look at my order. So my order for matrix A is a 3 by 2, and my order for matrix B is a 2 by 4. So according to the requirements, these two numbers have to be the same. My number of columns for A has to match my number of rows for B, and it does. These are the same, so that's telling me that yes, I can multiply these two matrices together, and when I multiply these two matrices together, my new matrix, or my new order, is going to be a 3 by 4. All right, let's try a couple more of these. So let's try example 2. Can we multiply B times A, right? So instead of going A times B, we're just going to flip those around. So again, we got to look at our orders. So our order for B is a 2 by 4. Our order for A is a 3 by 2. In order to multiply these together, these have to match. And are these the same? No, they are not. So that tells us that we cannot multiply B times A. So this would be undefined. Okay. All right. Let's keep rolling with some more. Let's try example 3. Oh, I don't know. What do you guys want to multiply? C times C. Because you can multiply matrices to themselves. Maybe, maybe not, right? So same rules still apply. We need to look at the order. So the order of C is a 3 by 3, and the order of C is a 3 by 3. I need to check my innards, and my innards are the same. So that means I can multiply these two matrices together. And when I multiply those two matrices together, my new order is going to be a 3 by 3. All right. What about, I'm having fun now. Let's try example 4. So example 4, if we could multiply C times C, I wonder if we can do A times A. So what was my order of A? A 3 by 2. And my order of A again is a 3 by 2. So I'm going to check those inner numbers, and I have a 2 and a 3. So these have to be the same. Are they the same? No, they are not. So that means that this is undefined. So unfortunately, or fortunately, we cannot multiply A times A together, right? Last little example, running out of space. I want you guys to try this one. Can we multiply matrix C by matrix A? And if so, what's the new order? So go ahead and pause the video and work through the problem, and I'll be waiting for you. No, seriously, hit the pause button. You know, the two little lines. Got it? All right. When you're done, unpause it and we'll keep going. All right. So looking at our orders, C is a 3 by 3. A is a 3 by 2. I see that these are the same, so that tells me that yes, I can multiply these two matrices together, and my new matrix, and my new order of that new matrix is going to be a 3 by 2. So how does this all look once we start putting in some values? I'm going to say matrix A, and I'm just going to use letters for this first example. I'm going to go A, B, C, D. And I'm going to say matrix B is E, F, G, H. right? So we're still going to sit there and make sure that we can multiply these two matrices together, because ultimately I want to do A times B. So my order of an A is 2 by 2. My order of B is 2 by 2. And these are the same. And my new matrix is going to be a 2 by 2. Okay? So let's go through the steps to figure out each one of those entries. So for A, I'm just going to start off by writing the top row. And for B, I'm going to start by just writing the first column. In a nutshell, we're ultimately going to multiply each element of row 1 by the corresponding element in column 1. And then we're going to add those together. So if I draw my matrix, and I'm going to write it kind of big for you guys. So my first element is A, and I'm going to multiply that by the first element in the other column, in the first column of the second matrix, which is A. So I'm going to do A times E. And then I'm going to add on to that. I'm going to take B, which is in that second position, and I'm going to multiply it by G, which is in that second position, right? Those corresponding parts. So I would have B, G. And that would give me my new matrix. It would give me my row 1, column 1 position. And I'm still a 2 by 2, so I still need to figure out row 1, column 2, row 2, each one of those elements. So I'm just going to leave that up there, and I'm just going to kind of do this nice and long for you guys. So again, we're going to start with AB, but we already fulfilled that first column, so we're going to move on to the second column. And that second column is F and H, right? So now when it comes to, I'm going to use that same idea of multiplying the elements in row 1 by those corresponding elements in column 2. So I'm going to have A times F, right? And then I'm going to add on to that B times H. And that's going to be in my first row, second column. I'm going to have AF plus BH. And if I put those two matrices together, right, I technically can put these together, and that fulfilled my entire first row. So I still have to figure out my bottom row. So to figure out my bottom row, I'm going to start off with that first matrix, but I'm done with AB. So I'm just going to look at CD, and I'm going to look at that with that first column, which was EG. So in my new matrix, this is going to give me my second row, first column entry. So I'm going to multiply those corresponding parts together. So C times E plus D times G, right? And when I figure these out, I just kind of think of firsts and seconds, or thirds and thirds, right? First times first, second times second. As these get bigger, it would be the third times the third and the fourth times the fourth. So that gives us that component. And then now we have that last piece, right? We have that second column, which is F and H. So in order to multiply these together, we're going to be figuring out that second row, second column. So those first corresponding parts is going to be C times F, and then the second ones are going to be D times H, right? And then once that all gets put together, we would have all of the parts of the matrix. I'm going to put together a second video, which we're actually just going to go through some numeric examples. So I'm going to stop this video for right now, and then we're going to move on to the second video where we actually do some examples with some numbers. Hope this helps. Talk to you soon.